For our Module 5 test, we have 4 main parts. So we have writing a ratio, finding equivalent ratios, then using those ratios to find a unit rate, and then applying the unit rate. So 4 parts will be on our test. So let's take a look at an example of each part of the test. So the first part is just to write the ratio. So there are 14 girls and 12 boys in our class. And so this one asks to write the ratio as girls to boys. So it's really important that we go in the order the ratio asks. So this one wants girls first, then boys. So we want girls first. There are 14 girls. And we use the colon. And then there are 12 boys. So 14 girls to 12 boys. Girls first, boys second, because that's what this problem specifically asked for. Another way to write a ratio is we can write it as a fraction, 14 to 12, which is what I will be using later, is the fraction method. Or we can also write it as 14 to 12. So any of these answers are correct as long as it goes in the correct order that the problem asked for. Another one that it asks for is boys. So we want boys first. Excuse me. So boys first, which is 12. There are 12 boys. And then it wants us to compare that to the total. We have 14 boys and we have 12 girls. We're going to put all of the kids together to see how many total kids there are. So there is 6 and 2, so we have 26 total students. So 12 boys to 26 total students. I can write it as a fraction, 12 over 26. And I can write it with the word 2, 12 to 26. Just order is really important. What did it ask for first? What did it ask for second? The next part of our test is on equivalent ratios. So once you know the first ratio, then you can use that to write equivalent ratios. And our rule is what you do to one side, you have to do to the other. So we need to fill in all of these blanks. So we can see right here, we have a whole section filled out. We know 4 and 6 is a ratio, 4 to 6. So we're just going to fill in this first one here. So we want to ask ourselves, how did I get from 6 to 3? 6 to 3, well, it got smaller, and we always have to multiply and divide to make equivalent ratios. So it got smaller, so I cut it in half. I divided by 2. And what I do to one side, I have to do to the other. So I have to divide this side by 2 as well. 4 divided by 2 is 2. So this one is 2. So now that I have this is my basic ratio. It can't get any smaller than 2 and 3. Nothing else goes into 2 and 3 besides 1, and it can't get any smaller, my basic ratio. So now I really want to use this basic ratio because that's going to make my numbers just a little bit smaller as I am working. So I don't have to multiply with and divide with some big numbers. Always use our smallest ones. So looking from here, let me get back to my pen. So now I'm going to ask myself, how did I get from 2 to 6? 2, 4, 6, I times by 3. So we can write that I times by 3. What I do to one side, I do to the other. So this one has to be 3 times 3 is 9. Now I have this one here, and we want to be careful that we don't just start skip counting, because it did start 3, 6, 9, but notice it doesn't go 12. So we have to be careful not to just skip count. Pay attention to what the order of the chart says. So now we're going from 3 to 18, 3, 6, 9, 12, 15, 18. So that is times by 6. So now I have to do 2 times 6 is 12. Now I have 27 down here. 3, 6, 9, 12, 15, 18, 21, 24, 27. Oh, perfect. Exactly 9 times. So times 9. It's always nice when you have 9 fingers, I guess, right? So 2 times 9 is 18. And then we've got a 22 down here. So to get from 2 to 22, I count by 2s till I get to 22, which is 11 times. 2 times 11 is 22. So 3 times 11 is 33. So all of these are now equivalent to our basic ratio of 2/3. Find your basic ratio and then you can find anything from there. So the other part of equivalent ratios will look like this, and it will give you a chart already filled out. So this one has 4 different classes, and they're girls and they're boys in their classes, and it wants to know which 2 classes have an equivalent ratio of boys to girls. So boys to girls or girls to boys. I'm actually going to flip that around so it goes in order of the chart. Girls to boys. There we go. So girls to boys. So looking here, I can see 12 does not nicely cannot nicely turn into 20 or 15. 15 doesn't nicely turn into 20 or 12. So it's not looking like I have one I can just multiply by 2 or 3 and turn into another one. So what I want to do here, remember we found our basic ratio. That's what we want to do here is find our basic ratio. So we want to think what goes into 12 and 20. So I'm going to start thinking of things that can go into 12. So I'm going to start with 12. Can 12 go into 20? No. 11, no. 10, no. 9, no. 8, no. 7, no. 6, no. 5, no. 4. Oh, yes, 4 goes into both of those. So I always start big and work down because I want to find the biggest number that goes into both of them. So 12 divided by 4 is 3. 20 divided by 4 is 5. So the basic ratio for Richard's class of girls to boys is for every 3 girls, there are 5 boys. So let's see what Mrs. or Mr., Mrs., we don't know, Giraldi's class is 20 to 12. So already I can see that these are backwards. Richard's and Giraldi are not going to be the same. Let's see what it is. So, right, we already know the factor that goes into 12 and 20 was 4. So we can divide 20 by 4 is 5. 12 divided by 4 is 3. So these are actually opposites of each other. They're not equivalent, or opposites. Okay, let's check out Franklin's basic ratio. So we're looking for something that goes into 15 and 24. So 15 can't go into 24. 14, 13, 12, 11, 10, 9, no, 8, 7, 6, nope, 6 doesn't go in there. 5, nope, doesn't go in there. 4, no, it doesn't go in there. 3, oh, 3 goes into both of those. Let's try out 3. 15 divided by 3 is 5. Ooh, so these are looking maybe like a match. Let's see. 24 divided by 3 is, 8. Not a match. So, right, this one got smaller and then this one got bigger. They've got to both do the same thing. If one gets bigger, then the other has to get bigger. If one gets smaller, the other has to get smaller, right? What we do to one, we have to do to the other. So, not a match. Okay, so let's see. This one hopefully will match to one of them. So 15 and 25. Oh, I can see how nice they both end in 5. So they're both divisible by 5. 15 divided by 5 is 3. 25 divided by 5 is 5. So now I can see that Richards and Skinner both have an equivalent ratio of every time they have 3 girls, they have 5 boys. So this one, it just times by 4. This one times by 5, but they have that same basic ratio. So simplify them. It's just like simplifying a fraction. Simplify them, see which ones match. Okay, the next part is our unit rates. And we have a bag of grapes that cost $14. Sorry, whoa, that's a very expensive bag of grapes. $4.16 for 4 pounds. What was the cost per pound of grapes? So let's remember a unit is 1. And every time I see this word per, I want to stick a 1 in front after that. What is the cost per 1 pound of grapes? So we've learned a couple different strategies that you can use to solve this. So you could set up a table, like the equivalent tables we just practiced. And I am comparing money and I am comparing pounds. Either way I do this problem, I have to know what are the two things I'm comparing. So I've got money and I've got pounds. My money is $4.16. My pounds is 4. And I want to know, what is the cost going to be? How much money if I buy one unit of grapes, 1 pound of grapes? So how do I get from 4 to 1? Just like we did on our charts, right? You either multiply or divide. So I'm getting smaller, so I need to divide by 4. So I would want to divide by 4. So that's one way to set up a problem. Another way, and a way I like to do it, is I think about what am I looking at. So I've got my money and I've got my pounds, and I set it up sideways. My money is $4.16. My pounds is 4, and I set it up like a fraction. So that's still a ratio. And I'm looking for how much money does 1 pound cost. Now notice, right? Every time we talked about pounds, I put it in the same row. Every time I talked about pounds, I lined them up. That's the key to this. So for this one, we're going to cross multiply here. $4.16 times 1 is 1. And then we're going to divide by this leftover piece is 4. So we're going to, either way I set this up, I ended up doing the problem $4.16 divided by 4. So that goes in there one time. There's 0 left over, bring down the 1. 4 cannot go into 1, but I still have to put that 0 up there. Every time something goes down, something has to go up. And then I'm going to bring down my 6, and that goes in there 4 times with my decimal. So 1 pound of grapes is $1.04. So that's a unit rate. A unit is always 1. How much is 1 going to be? So you can set it up as a chart or as a proportion, but you just got to keep everything lined up. So this one you cross to see, multiply. What are you going to divide by? I like this strategy because you'll see why on the next one, is because it can help me actually skip a step. So I only have to do 1 problem instead of 2. So now we're going to apply a unit rate. So Trevor mowed 6 lawns and made $80. So he is mowing lawns and he is making money. So those are my 2 things that are happening. So he's mowing lawns and he has money. So when he did 6 lawns, he made $80. So I set up, what do I know from the start? 6 lawns is $80 every single time. 6 lawns, $80. Then it asks, at that same rate, how many lawns? So I'm looking for the lawns up here. I'm looking for this, the lawns. Does he need to mow to earn $200? I want $200. Dollars goes on the bottom. So I could find how much 1 lawn is and then skip over and then do 200. But by setting it up as this proportion, I can actually skip that step and just do it all as one big problem. So what I need to do is 6 times 200, and then I'm going to divide it by 80. So 6 times 200 is 1,200. 6 times 2, 12 with 2 zeros, and I'm dividing by 80. So we are going to put an X here because it can't go into 1, can't go into 12, but it can go into 120 one time. 1 times 80 is 80. There are 40 left over. Bring down a 0, right? This is like 8 and 40. 8 goes into 40 5 times. So to earn $200, he needs to mow 15 lawns. So I could have figured out how much one lawn is and then times that to get to here. But it was a lot easier for me to just set it up and say, he has 6 lawns for $80. I want to know the lawns for $200. So I saved myself some time and some steps by just setting it up as one problem here. So this proportion helps me know, what am I going to multiply? What am I going to divide by? I could have even set it up upside down if I wanted to. I could have put money on the top and said he earned $80 and that was for 6 lawns. As long as I put my money on the top, he wants $200. How many lawns is that? So look, here's what I know, crisscross. So I'm looking for this. This is what I want. Divide by the one that's left over. Divide by 80 will tell me my lawns. So I did the same problem. It doesn't matter how you set it up as long as you match your 2 categories every time. So those are the 4 parts to our test. If you watch this video, there is a magic word. It is, okay, the magic word is actually going to be a phrase, and it is, Mrs. Richards, thank you for teaching me math. And if you say that to me, I have a special prize for you. Mrs. Richards, thank you for teaching me math. I have a special prize for you, and that will tell me that you watched this video and practiced for our test. So thanks for being awesome math students.